Today's training program will consist of 3 parts. The first part is this quick technical presentation where we will go over the fire suppression mechanics of an encapsulator agent and show you how it differs from a wetting agent or foam. The second portion of the program will be a field demonstration where we will perform a series of live Class A and Class B fires and encapsulation scenarios to demonstrate what has been discussed in the classroom. The third segment of the program will consist of a question and answer session on encapsulator technology and applications, including a written test. In addition to the encapsulator agent presentation and the demonstration, there are handouts, including an excerpt from NFPA 18, Fire Department testimonials, material safety data sheet, and a sales brochure from Hazard Control Technologies. Today's learning objectives include listing 5 benefits of using F500 encapsulator agent. We will review the classes of fires, identify various flammable liquids, and explain how surface tension reduction is important to fire and vapor mitigation. We will also describe how an encapsulator agent can combine with water and render flammable hydrocarbons non-flammable. We hope what you learn here will help you deal with the various hazards you frequently encounter. Understanding encapsulator agent technology will give you the knowledge to extinguish Class A and B fires more quickly, as well as reduce the risk of explosion, burn back, and steam and toxic smoke hazards. The ISO 9001 standard ensures that a company has been certified to have quality management systems in place, which helps assure product consistency. A major attribute of F500 is the multi-purpose and multi-dimensional use of the product on so many classes and types of fires. As you can see here, F500 can handle the variety of events we may face daily. Here you can see a few of the Class A fires that F500 can assist with. The surface tension reduction and penetration capabilities aid in quick and final extinguishment of these materials. This slide shows 2 different types of flammable liquids, polar and nonpolar. Hydrocarbons are nonpolar and do not mix with water, where polar solvents such as alcohol are soluble in water. F500 can be used on both types of Class B fuels using the same nozzle techniques. Different foams would be needed to handle Class B polar and nonpolar. Fire agent testing is often done on pans of Class B liquids, but in the real world, firefighters are faced with 3-dimensional fires. Foam cannot extinguish 3-dimensional fires because the foam must lay on the fuel and smother it. F500 encapsulates the vapors and cools the vessel and can extinguish these challenging fires. Another aspect of Class B fires is flammable gases. F500 has been used on propane, which is basically a 3-dimensional fire. Later you will see a video where F500 extinguishes a high-temperature Class D magnesium fire. This capability is due to F500's remarkable ability to cool. F500 has also been tested by Con Edison and FDNY for use on Class C electrical fires in a standoff leakage test. F500 at 3% with water can safely be used on an electrically charged transformer fire at 345,000 kilovolts with a 40-degree disperse spray pattern. Compared to traditional firefighting foams, the flow rates are much lower using F500 because of the quick cooling, encapsulating, and micelle formation providing complete extinguishment. The recommended proportion of F500 to water on Class B fires is 3%. Hazard Control Technologies presents F500 encapsulator technology. Whether it's a Class A or Class B fire, these videos show F500 encapsulator agents' quick knockdown capability and rapid cooling. These fires are extinguished in seconds. F500 encapsulator agent is not a foam and it is not a wetting agent. Current standards apply to one or the other. An encapsulator agent does not create foam because it does not smother the fire. More on that later. It does have some characteristics of a wetting agent, but it is more than a wetting agent. Ultimately, it is a triangular peg that doesn't fit in a round or square hole. What is F500? F500 is an encapsulator agent for Class A and B fires and an excellent spill control agent. It also has CULUS classification. The fire tetrahedron shows us that in order to extinguish a fire, we must eliminate one or more legs of the fire tetrahedron. F500 works on 3 legs at the same time, reducing heat, fuel, and interrupting the free radical chain reaction. Foam only separates the fuel from the oxygen, one leg of the fire tetrahedron, by creating a blanket of foam. The foam holds the heat, which often is why reignition occurs after the fire was extinguished. The large F500 molecule is referred to as an amphipathic molecule, which has both a polar end that is hydrophilic or water-seeking, and a nonpolar end that is drawn to other like molecules such as hydrocarbons. The molecular weight of F500 is greater than 1,000 compared to a water droplet, which has a weight of 18. Because of F500's size, it is capable of having both a positive and negative end and able to act independently. Now we talk about micelle formation, which essentially means that when F500 is added to the water at a 3% rate and applied to the fuel, a micelle is formed and now will encapsulate the hydrocarbon molecule by forming a chemical bond or cocoon around that fuel molecule, which will now render the vapor and liquid non-flammable and non-combustible. A strong chemical bond is created. Notice the size of the plain water droplet compared to the fire suppression agent and the F500 encapsulator agent. Both the fire suppression agent and the F500 have wetting agents that reduce the surface tension of the water and allow it to have smaller water droplets. This allows fire suppression agents to help water be more effective, but F500 goes a huge step further by encapsulating each small drop. Rather than just presenting small droplets of water, the tiny encapsulated droplets will seek hydrocarbon molecules and envelop them. Therefore, the first fire suppression asset is the surface tension reduction. This is the breakdown of the high tension of the water droplet, allowing for more surface contact area with the same volume of water. Imagine the droplets spreading out when F500 is added to it. The pictures show how large water molecule with high surface tension can't sink into the pores of a fuel source, leaving heat throughout the surface. A fire suppression agent like F500, on the other hand, has low surface tension and gets into the pores of the fuel. This piece of graph paper shows that when you reduce the surface tension, just how much more surface contact area is covered when using a standard mixture of 3% F500 and water, the same percentage that would be used on a Class B fire. The more surface contact area, the quicker the fire is cooled and extinguished. This NFPA 18 standard excerpt indicates that when wetting agents are added to water, it will increase the firefighting effectiveness, reduce the heat, penetrate materials, and provide for more complete extinguishment. We've covered surface tension reduction. Now we'll cover rapid and permanent heat reduction. A very unique feature of F500 encapsulator agent is heat reduction. As the amphipathic molecules form around water droplets, they efficiently draw heat from the fire into each water drop. This demonstration at the Georgia Fire Academy shows the cooling capabilities of F500. A propane torch is used on the opposite side of the steel plate to heat the paint to its auto-ignition temperature. A laser pyrometer is used to monitor the temperature, which peaks at about 1300 degrees Fahrenheit. A 2.5-gallon fire extinguisher with a pint of F500 encapsulator agent is used to apply the F500 mixture to the steel. In seconds after applying the mixture, the temperature has dropped from 1300 degrees to 100 degrees, and the surface fire is automatically extinguished due to permanent heat reduction. The firefighter is able to remove his glove and place his hand on the steel. Neither plain water nor any other additive can achieve cooling results like this. This demonstration shows how violently water reacts with burning magnesium. Although magnesium melts at 1200 degrees Fahrenheit, its flames can reach 5600 degrees. Adding water to the flames creates explosive hydrogen. Though only 3% of F500 is used with the water in this fire extinguisher, this mixture no longer reacts like water. The F500 surrounds the water droplets, protecting the water from the intense heat, preventing the formation of hydrogen. Instead, F500's remarkable cooling ability quickly removes the heat. In this slide, the Clemson University tests on heat dissipation show that this steel coupon, heated to almost 1200 degrees Fahrenheit, is quickly cooled to 127 degrees seconds after the F500 and water mixture is applied, without a climb in temperature. Comparatively, the traditional foam agent actually insulates and traps the heat with a blanket of foam. Notice a minute after the test was initiated, the temperature of the foam test is still well above 600 degrees Fahrenheit, well above the auto-ignition temperature of many common hydrocarbons. If the blanket of foam breaks down, the fuel will reignite. Next, we'll cover encapsulation. After rapid heat reduction, the second very unique feature of F500 encapsulator agent is its ability to encapsulate hydrocarbon molecules. This cross-section of a micelle or cocoon shows the encapsulated water droplets completely surrounding the hydrocarbon molecules. After surrounding the water droplets, the nonpolar tails go out seeking hydrocarbon molecules. They form this micelle. In this video, the firefighter approaches the burning jet fuel with a 40-degree sweeping motion. The suppression objective in this type of fire is to sweep across the surface of the jet fuel, encapsulating the hydrocarbon vapor, permanently cooling the fuel and the steel tank. After extinguishing the fire, the instructor puts his hand in the fuel and on the side of the tank, which are now both cool. This is permanent burn back resistance using F500 encapsulator agent. This video captured a training exercise in Dubai, United Arab Emirates, simulating a three-dimensional fire on a jet engine cowling. After the jet fuel was ignited, a mixture of salt water and 3% F500 at 87 psi is used to attack the fire. The firefighters use a 1.5-inch handline, 95 gallon per minute nozzle, and eductor. The fire was extinguished in 23 seconds. Foam cannot fight this type of fire. This simulation at the Marine Institute in Canada shows a ruptured 4-inch gasoline line. The 3% mixture of F500 is used with a 95 gallon per minute nozzle and eductor. Notice the firefighters are not trying to create a layer of foam, but cooling the vessel and allowing the F500 to encapsulate the hydrocarbon molecules. The fire is out in 13 seconds.
In this segment, we're going to show the F500's capability to neutralize the gasoline. We've poured 1 gallon of gasoline in the pan. Now we've put 1 pint of F500 in that solution. We're mixing it with plain water, about 4 gallons. What's taking place here is the F500 works on the molecular side, or the molecular bonding of the hydrocarbon molecule. As you can see here, the micelle, which is created, locks up that hydrocarbon molecule now, rendering that gasoline non-combustible and non-flammable. This is important in a fuel spill situation, for example. We take the LEL meter now. Our explosive limits are now to 0. We remove the threat of explosion. We can also take it one step further, where we take that neutralized gasoline now that's non-flammable and actually extinguish these tires that are now at 1200 degrees, which shows up on the laser pyrometer. You can see that we penetrated through the rubber, removing the heat from the steel core of the tire, shutting down the burn of the rubber, with giving us extinguishment on those tires. Again, 2 points here. We removed the flammability of the gasoline. We made it neutral with the presence of F500. We also obtain our suppression capabilities because we penetrate through and cool, and that's one of the factors of F500 is its cooling capabilities. We've removed the threat now, both with the fuel and able to extinguish these tires at the same time. As you can see, it took us 23 seconds to accomplish that.
To neutralize hydrocarbon fuels, you need a 2.5% solution of F500 in water. This will render a hydrocarbon fuel non-flammable and harmless. This works out to a ratio of 1 part F500 and 40 parts water to 8 parts of fuel. So for example, you want to neutralize a gasoline spill from a car on the highway. With a 20-gallon gas tank, you would need 2.5 gallons of F500 and 100 gallons of water. This is not to be confused with actually fighting a Class B fire. Here you would want a 3% solution of F500 in water and 1% F500 for a Class A fire. This demonstration shows a large gasoline spill. Half is treated with 3% F500 solution. Flame is applied but only ignites the non-treated area. Then the fire is extinguished using a dispersed spray pattern sweeping over the surface. The F500 encapsulates the gasoline vapor molecules, rendering them instantly non-flammable and non-ignitable. You will notice at one point the firefighter with the torch will disperse the F500 solution on the ground without any reignition. If this were foam, the gasoline would have reignited where he kicked the foam aside, because foam only lays on the surface and does not encapsulate.
What we're going to do today is spill this 5 gallons of ethanol, E85. It's 85% ethanol, 15% gasoline. This is what you're going to find at the gas stations now around the world. What we're going to do is spill it. I'm going to neutralize one half of it, and then I'll ignite the other half. What you're going to see is where we've mitigated it with 3% F500 through the hand line, which is a typical hand line for a fire department responding to, inch-and-a-half hand line, 3%, 95 gallon per minute nozzle. We're going to neutralize one half and then extinguish the other half that's on fire.
To reduce our dependency on foreign oil, it has become common to mix ethanol into gasoline. More and more flex fuel vehicles are capable of using a newer fuel that is being shipped around the country called E85, which is 85% ethanol and only 15% gasoline. A very specific ARAFFF foam must be used to fight these ethanol fires. F500 has successfully extinguished several ethanol and E85 fuel fires quickly and permanently without the chance of reignition. Here, the firefighter spreads out 5 gallons of the E85, covering about 500 square feet. The untreated half ignites. The treated portion has been rendered non-flammable. The F500 mixture quickly extinguishes the remaining fire, making the entire 5 gallons of E85 non-flammable. The residue will evaporate and runoff is very limited compared to an NFPA 11 foam application previously discussed.
So now we've mitigated the spill. We've actually put out the fire with the 3% F500 through this hand line with the dispersed pattern. Now I'm going to go back with the torch, make sure it's not ignitable. This is a 1200 degree torch head, and of course if there was any vapors there for it to be ignitable, they would have ignited, we'd have a fire right now. So we've actually mitigated the spill, put the spill fire out. Now this product is non-flammable, non-combustible liquid.
The NFPA 11 standard on foam states that in a non-dike spill, such as a spill on a highway, foam must be applied for 15 minutes on hydrocarbons to prevent ignition. F500 is an encapsulator agent and does not work that way. Once F500 has encapsulated the hydrocarbon, it forms a molecular bond that won't break down. To mitigate a hydrocarbon spill, NFPA 11 requires foam be applied for 15 minutes at 3%, at 1/10 of a gallon per square foot. F500 extinguishes the fire quickly, but has one other major attribute as a U.S. EPA-listed surface washing agent. Once applied, the F500 encapsulates the hydrocarbons, rendering them non-flammable. In the table, we want to mitigate an 800 square foot spill. We can estimate the 800 square foot spill resulted from 8 gallons of fuel. To encapsulate 8 gallons of hydrocarbon for a spill, you need 1 gallon of F500 and 40 gallons of water. NFPA says foam must be applied for 15 minutes, whereas F500 will take only 16 seconds. At 3%, the foam will use 1,200 gallons of water. The F500 will only use 40 gallons of water. Per NFPA 11, there will be 36 gallons of foam used compared to only 1 gallon of F500. Once the foam blanket breaks down, the fuel is again exposed to the oxygen, so the foam will have to be reapplied until the temperature of the fuel drops. Then an absorbent will need to be applied and it will be cleaned up and hauled off as hazardous, flammable material. On the other hand, the F500 and the encapsulated hydrocarbon will simply evaporate. Aside from the cost of the foam, 36 gallons, versus F500, only 1 gallon, the cleanup costs are alarming. The last portion of the fire suppression mechanics is the interruption of the free radical chain reaction. Essentially, the large F500 molecule absorbs a great amount of heat energy, which inhibits the combustion process, reducing the smoke, heat, and vapors, while aiding in the final extinguishment process. This completes the suppression initiatives. This Clemson University test showed that when F500 in water was applied to burning rubber, the visibility was increased 70% in seconds. This brings us to F500's unique feature number 3, the ability to interrupt the free radical chain reaction. This reduces toxic smoke and soot and increases visibility. Without the smoke, firefighters can better see what's going on, possibly saving lives. This fiberglass boat fire was extinguished in seconds using a 95-gallon per minute structural nozzle with a 0.5% F500 mixture, permanently reducing the heat from 1,000 degrees Fahrenheit to 100 degrees without the threat of reignition. Foam would have had to have formed a blanket across the cavity of the boat with reapplication until the heat dissipated on its own. This video shows a direct comparison between F500 encapsulating agent and Class A foam delivered through a compressed air foam system on 2 separate piles of 40 tires. The department on the left is being trained on the proper application of F500. The fire department on the right chastised the fire department on the left for purchasing F500, believing Class A foam through a CAFS is the wave of the future. In the video, you will see F500 knockdown and extinguishment in 10 seconds. If you listen closely, at around 13 seconds, you can hear the CAFS compressor just getting revved up. It then takes the foam and CAFS 2 minutes and 12 seconds to put out the fire. The F500 cools the tires, providing burn-back resistance. Without heat, there can be no fire. As foam tries to smother the fire, it traps the heat. About 2 minutes into the exercise, the foam has almost extinguished the fire. Notice the smoke rising straight up. That is because the tires are still generating plenty of heat. Later that night, the foam blanket breaks down, the fuel comes into contact with the oxygen, and reignition occurs. This training fire near Ontario, Canada, featured a house staged inside with tires, hay bales, and furniture with the goal of saving people that could be trapped in the left side of the house. Using a 0.5% solution of F500 encapsulator agent, the fire was easily attacked from the front door. Everywhere the F500 was used, extinguished the flames and prevented reignition. Notice as the black smoke quickly changes to a harmless, low-temperature, non-toxic white vapor of encapsulated fuel. Without the presence of superheated steam and black smoke, the firefighters can safely escort the trapped people out of the building. The fire was extinguished in about 23 seconds, utilizing an estimated 50 gallons of water and a pint of F500 encapsulator agent. The ability of F500 to make water more effective is critical. Let's review the fire suppression mechanics. Surface tension reduction allows F500 to make water more effective by reducing the size of the water droplets and allowing the water to spread out, drawing the heat from every pore in solid fuels and better encapsulating liquid fuels. F500 encapsulator agent instantly draws the heat from the fuel and surrounding structure, eliminating burnback. The micelles are formed around the liquid fuel and vapors, rendering them non-flammable. And finally, F500 absorbs the free radical energy, reducing toxic smoke and soot, resulting in better visibility and air quality. In the firefighting business, we always have to be aware of what we do to the environment. Using F500 allows us to mitigate many hazards and yet be environmentally responsible. F500 encapsulator agent is non-corrosive, non-toxic, non-hazardous, and 100% fully biodegradable. F500 has been listed by the US EPA as a surface washing agent for fuel spills on roadways, on the shore, shoreline, rocks, pilings, piers, and wharfs to encapsulate and render them non-flammable. Now that we know what F500 is, let's take a look at the benefits of using F500 during operations. Heat and smoke reduction is a huge benefit of using F500 in your water stream. The F500 molecule encapsulates airborne toxic particulates, allowing for an increase in visibility and a reduction in smoke. In addition to heat and smoke reduction, F500 can mitigate vapors, both airborne and on the surface, by applying a 3% F500 in water application to the source, which reduces explosion hazards, renders the fuel non-flammable, reduces burnback and flashover, and increases safety. These properties also allow F500 to be used for spill mitigation and even tank cleaning. In addition, F500 is friendly to the environment. This Clemson University study shows that with the use of toluene, vapors were reduced over 90% in just a few seconds after the application of F500 in water, allowing for a safer scene. F500 is not corrosive and meets UL standards for foam equipment UL 162 and NFPA's standard for wetting agents NFPA 18, although F500 is an encapsulator agent. It is not a foam nor a wetting agent. In this Clemson University corrosivity test, F500 is shown to be no more corrosive than plain water, therefore reducing the chance of equipment damage due to corrosion. Current UL standards reference the NFPA 18 standard governing wetting agents and how F500 has been found to meet the UL 162 equipment requirement. F500 can be used through any traditional foam delivery equipment, including nozzles, eductors, hose lines, etc. To summarize, F500 is not a foam and it is not a wetting agent. It is an encapsulator agent. We discussed how F500 eliminates 3 legs of the fire tetrahedron during the application. F500 is economically beneficial because one agent can handle Class A and Class B fires as well as mitigate spills. Also, less F500 is needed because it extinguishes the fire so quickly. Since less water is used, cleanup is less of a problem with less runoff, and F500 won't harm the environment. F500 is also safer because it quickly reduces toxic smoke and increases visibility. Finally, F500 can be used on a variety of applications on Class A and B fires, spill control, and even tank cleaning and soil washing bioremediation projects. A review of objectives, terminal performance objectives. Students will identify 5 benefits of using F500 and learn to properly apply F500 in a field demonstration on flammable liquids. Students should be able to answer the following. List the classes of fire and give an example of each. Identify 2 types of Class B flammable and combustible liquids. Explain how surface tension reduction increases surface contact area and why that is important when dealing with vapor and fire mitigation using hand lines and fog patterns. Also, describe how F500, when used with a percentage of water, can render Class B fuels inert, non-flammable, and non-combustible. And finally, identify 1 major point outlined in NFPA 11 standard on firefighting foams and NFPA 18 standard on water additives for fire suppression and vapor mitigation that would indicate a major operational difference between the 2 agents.